This video is sponsored by Brilliant. Hello, my name is Mr. Asprey and I've got a tricky question for you today. This is a MADAS Maths question, comes from the website, check it out, link in the description, great, loads of resources. And I've picked this one because you may be starting the topic sequences, and I thought this just looks like a really interesting question. So as always, pause it first, give it a go, and then here's the solution. Okay, so we've been asked to show that this series up until n is the sum starting with k equal to 1 up until when k equals n of the sum starting with r equal to 1 up until when r is equal to k of 2 to the r. Okay, so if you are not quite sure what to do for a series question, it's a good idea to either split the series up or to just write out some of the terms and see if you can spot a pattern. So we're going to start with this yellow summation here, and the series itself, I can't really split it up because it's 2 to the r, there's not much to work with there. What we can do is we can work out what each term is going to be when we substitute in the given r's. So we're going to start with 1, and that will be 2 to the 1, which is just 2. And then when r is 2, we're going to get 2 to the 2, which is 4. When r is 3, we're going to get 2 to the 3, which is 8. And then when r is 4, we're going to get 2 to the 4, which is 16. All the way up until the final value for r we substitute in, which will be the kth term. So yeah, we sub in k, so it was the kth term. And that will be 2 to the k. Okay, so, well, what's the pattern? Well, we are multiplying by 2 each time. So this is what we call a geometric series, because we are timesing by a common ratio each time, and then afterwards we're going to be adding them all up. Okay, so what is the sum of a geometric series? Well, that is a formula that is given to you, and it looks like this. It's the sum a1 minus r to the n all over 1 minus r. And in fact, you could also write it this way round. Some people prefer it this way round. It's an equivalent formula. You're just multiplying top and bottom by minus 1. So take your pick, whichever one you prefer. Okay, so for this particular series, a is equal to 2 because that's the first term, as you can see here. R is the common difference, so that's also equal to 2 because you're timesing by so r is the common ratio, sorry, not the difference, it's the ratio, and you're timesing by 2, so it's 2. And then n, the number of terms will be k, because you've got 1, 2, 3, 4, all the way up to k, so k is the number of terms. Okay, so let's then evaluate this and show us what it's going to give. So we're going to substitute. Let's substitute into this one. I think it's just going to be a bit neater, a bit nicer. So when a is 2, r is 2, n is k, minus 1, all over r is 2, minus 1. Perfect. And 2 minus 1, of course, is 1. So we're dividing by 1. So we can just get rid of that. Perfect. Okay, so that is the yellow part evaluated. So now we can go back over here and we can say that we are now looking for the sum starting when k is 1 up to when k is k is n of the yellow thing, which is this, which is 2k minus 1. Okay, so what I said before was that you can either write out the terms like this, like we did for the first one, or we can try and split up this summation. So this is going to lend itself to being split up because you can see here that there has a factor of 2. So we can literally just pull that out like we do a bracket. We could take out a factor of 2 like that. And this makes sense because what you're doing here is you're multiplying every term by 2 and then you're going to sum them all up, which is the same as just summing up all the terms then timesing by 2 to the result afterwards. Okay, and then that's going to give us 2k minus 1 inside, like so. And then we can take that a bit further as well. So what we can do is we can split up these two parts. So if you have a summation where there's 2 parts to it which are separated by a plus or a minus, then you can turn those into 2 separate summations. So you can add up all of the 2k's and then you can add up all of the 1's and you can, well, subtract them in this case. Now if I add up all the 1's, well, how many 1's are there going to be? There's going to be however many terms there are, so there's going to be n 1's. So that part there is going to simplify down to just n. Okay, so let's do a little bit of simplification. Well, what is this? Well, this is looking very similar to the yellow summation that we worked out earlier. In fact, it's exactly the same. We're just using different letters. So rather than our answer being 2 to the 2k minus 1, now it's going to be 2 to the 2n minus 1. And then this, like I said before, this is just us adding up 1 n times, which is just going to give us n. Okay, right, nearly there. So now we're just going to multiply the 2 into this square bracket to get 4 lots of 2n minus 1 minus 2n. And then we're going to say that this is equal to, well, 4 is the same as 2 to the 2. And then I'm going to multiply that by 2 to the n. And here I'm going to times that by 4, like so. So why have I written 4 as 2 to the 2 here? Well, because we've got now 2 and 2 multiplied together, so we just add the powers using our indice rules. So this becomes 2 to the n plus 2. There's a minus 4 and there's a minus 2n. I'll just write it this way round. And that is a wrap. And now a quick word from today's sponsor of this video, that is Brilliant. Now Brilliant is a website and app that helps you become a better thinker and problem solver with thousands of visual interactive lessons in maths, science, programming, data analysis and AI. What I love about Brilliant is how interactive it is, and it's helped me become a better teacher, but also it's helped me understand some topics that I've got no idea on. For example, programming. So something I'm looking at now is their new courses built around trying to get people better at programming, and as being a complete noob, I'm really looking forward to going through these lessons. So to get started for free, go to brilliant.org/Mr. Asprey or scan the QR code on screen or click the link in the description. And Brilliant's also giving away viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Bye for now.